Hi guys, welcome back. This short video is going to have three examples that are dealing with the second derivative test. This is from our calculus class, section 3.4. And first off, defining the second derivative test, as you can see right there, is an alternative way to find a function's max or min, where you plug in any critical number or critical value into the second derivative. And remembering that critical values are the zeros of the first derivative, or we also want to state not only the zeros of the first derivative, but also where they are undefined. So we know that we can get critical values from the zeros, or if our first derivative winds up being a rational function, it'll be the zeros from the top and the zeros from the bottom. So let's take a look here. If the second derivative is positive, then we have a relative minimum. Now that should make sense to you because you know that the second derivative being positive means that we are going to be concave up. And when we're concave up, we have that parabola like that, which means that we would have a minimum at the bottom. If the second derivative is negative, then we would have a maximum. Well, knowing that the second derivative is negative, we know that we are concave down, where we would have a maximum. If the second derivative winds up equaling 0, then the test fails and we have to go back to the first derivative test for increasing and decreasing functions. So let's take a look here at an example we got right here. Here we've got f of x is 2x cubed minus 3x squared minus 12x plus 5. So the very first thing I want to do is find the first and second derivative. So the first derivative we're going to see is just going to be, what, 6x squared minus 6x and minus 12. Alright, I'm also going to go ahead and find the second derivative. And so the second derivative is going to wind up being 12x minus 6. Okay? Now, before we do anything else here, we should know that, hopefully from pre-calc a little bit here, we've got a third degree polynomial, so that's a cubic. Leading coefficient's positive, so it should look something like that. Now that's very, very vague, but we should know that a cubic should have that shape, okay? Where we'll have a max here and a min here probably. Alright, so we got to take the critical values, and again, critical values come from the first derivative. We're going to set that equal to 0 and solve for x. Now it would be a lot easier to factor out a 6, and you got x squared minus x minus 2. And we just do some factoring here. So we'll have 6 on the front. A little FOIL factoring here. We'll have x minus 2 and x plus 1. And that tells us that our critical values are going to be at x equals 2 and negative 1. Okay? So now what we got to do is take these critical values, plug them into the second derivative, and see what we get. Alright, so if I plug in to my second derivative, 2. Now I really don't care what the number is. I just want to care if it's positive or negative. Alright, so I know if I plug in 2 here, I'm going to get 24 minus 6. That's going to be a positive answer. Now for the second derivative to be positive, that means I'm concave up, which means I look like this, which means this right here has got to be a minimum. Okay, sorry for the pen there acting up a little bit. Now I'll double check what happens when I plug in negative 1. So that's going to be 12 times negative 1 minus 6. And when I do that, that's going to be a negative minus another negative. That's going to be a negative, which means I'm going to be concave down, which means I'm going to have a maximum right here. So I've just proved with the second derivative test that at x equals 2, I'm going to have a minimum, and at negative 1, I'm going to have a maximum. Now, to actually get the x and y coordinate now, remember, anytime you need a y value, you got to go back to the original function. So I know that I'm going to have a minimum at 2 comma something, and I'll plug that in for you. When I plug in 2, okay, I know that I'm going to get negative 15. You can check that on your calculator. When you plug in 2 to the original. And I know that I'm going to have a max at negative 1. And again, plugging that back in the original, I have 12. So that's the second derivative test right there. That'll help you find a function's max or min. That's just an alternative way. All right, let's try another one here. All right, so I'll scroll down here. Hopefully not too far. If I can find it. All right, well, I can write it in, so no problem here. So let's say I've got f of x is equal to a negative x squared plus 4x minus 6. Now, again, before we do any work, we see that the original is a negative quadratic. Now, hopefully from Algebra 2, you know that a negative quadratic is an upside down parabola. So that tells us right away we should be getting a max, and just one of them. Okay, so let me find my first derivative. Okay, so my first derivative is going to wind up being negative 2x plus 4. And my second derivative is just going to wind up being negative 2. Now that should tip you off right there because there's no x, and if I plug in anything, it doesn't matter. My second derivative is negative. My second derivative being negative means I'm always going to be concave down like we talked about. All right, so let's find that critical value where the maximum is going to be. So I take the derivative and I set it equal to 0. So I'm going to have negative 2x, move the 4 to the other side, and I'll have negative 4. X is going to wind up being 2. And so when I do that, I know, again, I got nothing to plug in for the second derivative, but my second derivative is a negative constant here. So I know it's going to be a max. So I know I'm going to have a max at 2 comma something. And again, to get the y value, I got to go back to the original function. So plugging in 2 to the original function, I'll get negative 2, and that'll wind up being my max for that one. All right, so let's look at the last one that I'm going to do here that has the function failing, or the test failing. Okay, so I want to look at one like this. Let's say I've got y equals 3x to the 5th minus 5x cubed. Start the same way. I am going to find the first and second derivative. So the first derivative is going to wind up being 15x to the 4th minus 15x squared. And my second derivative is going to wind up being 60, 4 times 15, x cubed minus 30x. Okay, so now I got to figure out the concavity here and the zeros from the first derivative. So I'm going to set this equal to 0 right here. And probably easy if I take out a 15x squared. Little factoring here. And I know I'll have x squared minus 1. So that means I'll have critical values at x equals 0 from the first factor, and then plus or minus 1 for x squared minus 1 there. So plus 1 and minus 1. Alright, so I got to test 0, 1, and negative 1 into my second derivative. Okay, I'll do the plus and minus 1 here because that 0 is going to fail, but let's do the plus and minus 1. So if I evaluate negative 1 into that second derivative, okay, if I plug a negative 1 here, I'm going to get a negative and a positive there, but that's going to be bigger, so it's going to wind up being negative. Okay, which means that if a second derivative is negative, I'm going to be concave down. That means I got a max. Okay, and then the second derivative at 1. Alright, if I plug in 1 to the second derivative, I'll have 60 minus 30. That's going to be a positive answer, which means I'm concave up, which means I'm going to have a minimum. Alright, so right there, I know that I'm going to have a negative 1, and again, to get that y value, I got to plug it into the original function. Negative 1, 2 is going to be a max. And then at 1, get that y value, go back to the original. Negative 2, I'm going to have a minimum. Now, the one I haven't checked for the critical values is 0. So look what happens when I plug in 0 to the second derivative. I'll have 0 minus 0. So right here, you get 0. That means the test fails. Okay? And when the test fails, you've got to go back and do increasing and decreasing from the first derivative test. So we have to set up our little number line here at 0. Now remember, our other critical values are negative 1 and 1. So I got to pick numbers happening right around 0. So remember, we're increasing, decreasing. That goes back to the first derivative test. So I'm going to evaluate the first derivative at a half, and I'm going to evaluate the first derivative at a negative half and see what we get here. Now if you remember, if it's positive, we're going to be increasing, negative, we're going to be decreasing. So when I go back up here, my first derivative, now you can see that I got a fourth power and a squared power, so no matter what I plug in there, it's going to be positive. So we're going to wind up right here. Okay, when I go back to my first derivative, I'll have 15 times 0.5 squared, and then when you put that in your calculator, you're going to see that both of these, 0.5 and negative 0.5, are going to be negative. Okay, and therefore that means they are decreasing for both. Now since there was no change, that tells you that we do not have a max or a min going on right here for either one of those. So we know that our only max and min are going to happen from what we figured out with the second derivative test. So hopefully those 3 examples will help you there for when we talk about the second derivative test.